second term technology lesson. I am Lindy. I am your technology teacher for grade 9. And from today, I'll be teaching pneumatics and hydraulics. I want to first share with you what we'll be doing this term. We'll be using I'm trying to get my full screen here. I'm sorry, just a little bit. I want to get my screen okay here. Okay, it doesn't matter. We'll go this way. All right. I am Lindy. I'm a subject advisor, and I'll be doing with you mechanical systems and control for grade 9. And I would be happy if we actively participate. It's difficult for me to teach this way, but we will all adapt because our subject is very practical. I'm used to sharing equipment with my class and getting my learners to do practical work. But this time we'll just use what we have, which is today just the computers that we have. But at home, please, if you can, try and do the things that I will advise you to do at home, just to get a practical aspect of our lessons. All right, we'll start off in our systems and control lessons. We'll start with pneumatics and hydraulics. What we'll be using, this is what I will encourage you to get at home if you do have it. We will be using syringes. I will show you the video just now. Syringes, plastic tubing, a load of any sort. Okay, I will use a cool drink can in today's lesson. You'll see in one of my videos, I'll be using a cool drink can as load, but depending on the experiments that you'll be doing in any of our lessons in pneumatics and hydraulics, you will be using what is relevant, the load that will be relevant. I'll be advising you what to use every time. Textbooks, the textbooks that I recommend, I'm by no means employed by any publisher, so I will recommend the textbook that the department owns, which is the Sasol Inzalo workbook for technology. I hope some of you learners do have these at school, and if you don't, any other textbook that you have at school that you use normally at your school is acceptable. You can use that for reference. But for these lessons, I'll be taking a lot of my material from the Sasol Inzalo workbooks and from other sources that I will show you from the internet. Okay, are we together? Hello? I seem to be speaking alone. Hello? Okay. Right. Now, our lesson starts with a little bit of revision from pneumatics and hydraulics that you did in grade 7. Curriculum jumps up to grade 9. but I will show you this video so that you remember. Hello? I hope you can hear me now. I'm sorry about that disruption. My network was very bad. Okay. Okay. Can you hear me? Can you hear me on this one? Can you hear me on this one? Okay. I'm sorry about that disruption. It's the internet problem. So going back a bit, I said we will be using textbooks that you use at school and also the Sasol Inzalo workbooks. Now, this video that we just played was from your grade 7 Pneumatics and Hydraulics project, which was called The Jaws of Life. You did it in grade 7. So I hope that some of you can remember it, but you can identify the pneumatic system that is used there, which is what the syringes and the pipes, and that structure was made to connect to the system. But what is important here is to identify that in that system, you have here the driver and you have that as your follower. And then this is the input and this is the output. Okay, let us see. Now, looking back at your former grades, pneumatic and hydraulics, surely you need to know what materials can be compressed. I want you to quickly jot down your answers for these so that we make a quick revision of what we learned in the previous grades. Okay. What is it that you can compress between air, sand, and water? Choose the correct answer. So you just identify the correct answer. You just write that quickly. You jot it down. And now that we have lost so much time, I hope that you can quickly look at the questions there and jot down the answers. I'll give you just a few minutes to look at that. Okay. Now we can quickly look at the answers just to remember what is it that you need to know about pneumatics and hydraulics from your previous grades. Which of the following can be compressed, air, sand, or water? The correct answer there would be air. You can compress air. From your choice in question 1, can you give an example of what we have seen in your everyday life? Surely some of you have seen a compressor. That is compressed in. And A pneumatic braking system is another example of a pneumatic system. When we connect two syringes to a tube, we call it a syringe system. When the syringes are filled with, with air, we call it what? We call it a pneumatic system. Water or oil is used in a hydraulic or pneumatic system. The correct answer there is in a hydraulic system. In the video, the syringe is pushed by the finger, which is pushed by the finger, is called the master. It is called the master cylinder. Okay. The master or slave cylinder is also called the driven cylinder. The correct answer there is what? Is the slave cylinder. The slave cylinder is also called the driven cylinder. The input is on the driver or the driven cylinder. The correct answer there would be the input should be on your driver cylinder. So the master cylinder is also called the driver cylinder. That is where our input is. The output is on the driven cylinder. The system in the video is a pneumatic one because we do not see any water or any hydraulic fluid in this video that I showed you. Okay, so that answers number 10. So these should be your answers. These are the answers that I went through with you. Because of time, you didn't have time to jot them down so that you can quickly go over them on your own. Right. Now, in this chapter of pneumatics and hydraulics, we'll look at the following. We'll use the same syringes and pipes that we used in grade 7, but we'll be adapting our knowledge of that into the industrial world, into the real world, okay? We'll look at the following topics: the use of water and air to move objects. Obviously, that is hydraulic, water, air, pneumatics to move objects. And we'll look at syringes when we connect a system. When you use syringes of an equal size, I'll show you a video just now. We'll look at narrow and wide syringes. So after we have seen syringes of an equal size, we'll also see syringes of an unequal size. We'll also do action research on the transfer of pressure from one syringe to another. We'll use a video for that, okay? We'll look at change of force intensity. We'll look at Pascal's principles in that. Then we'll look at hydraulic machines in real life. Now moving from the tubes that we use in our class to what now? To the to real machines in the real world. Using pressure to get things done, looking at how pressure is used in pneumatic and hydraulic systems. We'll also do calculations about hydraulic systems. That will be our third lesson. We will also look at what we always see, the hydraulic car jack. We'll study that and see how it works. And then we'll make an evaluation of the design of the car jack. Why are these machines made like that? Okay, I hope you all can you can all still hear me. Now, in this video that I'm going to show you now, we have used syringes or cylinders of an equal size. Now, this is only a demonstration of the transfer of force in a hydraulic system. We've made a hydraulic system of our own. It's one that I made when I was with my colleagues. So I hope you will see. I have dyed the water so that you can see that it is a movement of water from one cylinder to the next. The cylinder that is held by the hands is the master cylinder, and the one that is pushing the load here is a cool drink can that I have used. So I hope that you will remember something when you look at this video. You can see there pulling the plunger of the master cylinder lowers the load from the slave cylinder. Look at the movement of the hydraulic fluid in the master cylinder from the slave cylinder now that the plunge is being pulled. So this is a process of pumping. So from here, we are going to pump the hydraulic fluid back into the slave cylinder. I want you to note that the movement here will cause the load to go up again because there is a transferring of pressure from the master cylinder to the slave cylinder. These syringes are of equal size. So the same amount of pressure that is applied here is the same amount of pressure that is put out here. So the input here is equal to the output. Okay. Yoliswa, you're asking something? Yoliswa? Please type so I can see because
No, ma'am, I didn't ask a question.
Oh, okay, Yoliswa. All right. Are we still together though? Okay. Now, we were looking at the transfer of pressure from this master cylinder to the slave cylinder. It has an effect of the transfer of the hydraulic fluid from the master cylinder into the slave cylinder. The pressure transfers force from the master cylinder into the slave cylinder. Now, this brings us to what we call the Pascal's principle. The video depicted above shows force transfer between two equal cylinders. The output cylinder moves the same distance as the input cylinder. Why? Basically because they are equal. Pressure is transmitted from the master cylinder to the slave cylinder through the water in the system. The water in a hydraulic system is called hydraulic fluid. When the pressure is applied to a container with liquid, the same pressure is felt everywhere in the container. The pressure is transmitted through the liquid. A man called Blaise Pascal found this out many years ago and wrote about it. This principle is called Pascal's principle. This video that we have just seen, it demonstrates what we call Pascal's principle. Pascal's principle is that when pressure is applied on a container or liquid, the same pressure is felt everywhere in the container. Learners, I want you to note that Pascal's principle applies only where there are no leaks in the container. There should be no leaks between the slave cylinder and the master cylinder and the slave cylinder. If there is any hydraulic fluid lost in the system, so Pascal's principle does not apply there. Okay. The blue liquid in the system transfers or transmits pressure from the master cylinder to the slave cylinder. The pressure then pushes the load, the soft drink can, up. When the liquid is pulled back from the slave cylinder back into the master, the load is lowered, as we all saw. Okay. Now, that is an application of Pascal's principle. If you want to do this at home, please make sure that there are no bubbles that are formed between your two cylinders, because the bubbles, they have an effect on the transmission of pressure. Okay. Now, in that video, we saw two equal syringes, but then the situation is different. The force transfer is different when there are two unequal syringes. If this small syringe here is the input cylinder, and this is the plunger, and this big cylinder here is the output cylinder. Can you imagine if this was our load? If we put one block here on the master cylinder, trying to have a movement on the output cylinder or the slave cylinder, surely there wouldn't be any movement here if we have only one block. So it means we would have to add more blocks here on the master cylinder to get a movement on the slave cylinder or the output cylinder. Why? Because the master cylinder is smaller than the slave cylinder. But if the situation was turned around, if this was the master cylinder and this was this slave cylinder, not much force would be applied onto the master cylinder if this was the master cylinder. So there is less effort to get an output here that is needed. We would maybe with one block get a movement on this side. At home, please practice that and experiment how much pressure, how much effort you have to apply on this. If you make this the master cylinder, how much effort do you have to apply? If you change the master cylinder to the smaller one, how much effort is it necessary to get a movement on the slave cylinder? Okay, we are just forming principles around that. Force intensity. Okay, I have explained the amount of force that you have to apply on two unequal cylinders. Okay, obviously, when the master cylinder is smaller, more effort, more force has to be applied. We obviously put more boxes on the master cylinder in order to get a movement on the slave cylinder. It is evident that more force was applied on the master cylinder to make the slave cylinder to move because it is bigger. the distance moved by the master cylinder will be more than the one moved by the slave cylinder because these cylinders are unequal, okay? And I have also explained to you that if you change the situation around, if the bigger cylinder is the master cylinder and the smaller one is the slave cylinder, you would have to put lesser blocks to get a movement on the slave cylinder if it is smaller, but you can experiment that at home too. Right. Now, in our systems in everyday life, we want our systems to give us more output than input. Okay, that is why we have machines. That is why we have car jacks. We want to make our lives easier. We will explore all that in the other lessons that I will be having with you. Hopefully, those will be much better than the one we had today. Okay. Tomorrow we'll look at other machines and the mechanical advantage that they give. All right. I hope tomorrow's lesson will be much better than the one we had today. Thank you. Okay. For your homework, please get yourselves 2 syringes, a pipe if you can. If you can't, it's not a problem because we have prepared the lessons for you so that you can see the demonstrations. And if you do bring them to class when you sit down to log in, so that while we are learning, you can experiment with that. Because some experiments, I will tell you what you can quickly connect. You know, it's not difficult to connect these pipes when you are seated comfortably, maybe enjoying the lesson.